Okay, welcome back. This is section 7-4. This is recording number 3. Okay, I've said this so many times, and I hope you believe me, and I hope that you're following my advice on this. It's so important to do the examples. If you do the examples line by line, writing out all the details, putting in all the explanation that you need to make sense to you, then you're going to understand this much, much better. Okay. In the long run, you spend less time. Trust me on this one. Okay. All right. So let's take a look at this example. We'll talk about women's ages, and we're going to find a confidence interval for the variance and for the standard deviation. So a study of 30 women. So N is 30. It's 30 women. Found the standard deviation of their ages was 5.2 years. Okay. So that is standard deviation. That gives me S. So this is S because it's a sample of 30 women. So S is 5.2. Find the 95% confidence interval. So if it's 95% confidence is what I'm looking for, then that means my error budget is 5%. I can be wrong 5% of the time. Alpha is 5%. Half of alpha is 2.5%. So the fact that it's 2.5% tells me where do I go on that table that I need to look at. Okay. And then it says, assume the variable is normally distributed. That is a requirement that it be normally distributed. And then I believe it's always very important that you be able to specifically, clearly be able to articulate the random variable. What is the random variable we're dealing with? The random variable is age. Okay, I'm talking about ages. All right, so here we go. Alpha is 0.05. The two critical values that we're looking for is half of that for each of those, right? We ignore this number down here. When we draw our cartoon, we want this to be 2.5%. We want this to be 2.5%. Okay, that's what we're looking for. Okay, so now what do we need to do? We need to find for 29 degrees of freedom, we need to find the two critical values. So since this is a video and it's not really class time, I'm hoping you're watching us. Let me go ahead and do it for you. Okay, I'll do this for you. Okay, I switched over to the PDF version of the textbook, this table here. All right, so on this particular problem, the N is 30, therefore the degree of freedom is 29. So here's 29 right here. That tells me that okay, I beg your pardon. Okay, a little technical difficulty there. So we are in the back of the book, this is table G, the chi-square distribution. N is 30, therefore the degrees of freedom is 29. There's the appropriate row, 29. Okay, so that part's easy enough. So now what we're looking for is which of these columns do we need, right? Okay, now the problem said they wanted to be 95% confident. That means that we have an error budget of 5%. We can be wrong 5% of the time. So half of the error budget is 2.5%. So what do I want? I want this row, this column right here, 0.025. That gives me the appropriate, I go down that column, that'll give me the appropriate, and I can't do it on the screen here because everything is too jammed together here. All right, having more technical difficulties, folks. Sorry about that. Oh boy, this is harder than it looks. Okay, unfortunately I just don't have the right software to write on the screen. If I could write on the screen like they do on Khan Academy, it'd be great, but I just can't do it. So I'm going to just have to say it. Okay, so what I want is I want the chi-squared right guy to be the guy that gives me the critical value. To the right of that critical value, to the right of chi-squared right, I want it to be 0.025%, right? Okay, so how do I do that? This is the appropriate row. This is the degree of freedom. It's 29. And then I come up here, 0.025. So 0.025, if I come down to 29, right there, 45.722. So 45.722, that's the appropriate critical value, the chi-squared right. For the chi-squared left, okay, this is a previous example, so you got to ignore all these numbers here, but the cartoon is, you want the number, the critical value that is 2.5% to the left of that critical value, the chi-squared left, and you want to have 97.5% to the right of that critical value. And you can kind of see that maybe better here. So chi-squared left, I want 2.5% over here, 97.5% over there. So what gives me that? Hang on. Okay, so if I want the 97.5% to the right, the appropriate column is here. This is my column. To the right of one of these numbers is 97.5%. But I got to choose wisely. I got to go to the appropriate degree of freedom, which is 29, 97.5, boom, 16.047. 16.047. I wrote that down on my scratch paper. Let me close this and let's see if I got that right. 16.047. Boom, there it is. Okay, so the chi-squared right, chi-squared left are those numbers. It's very, I can never memorize things. Okay, so you're just going to have to remember to draw these cartoons and remember which one is which. It says chi-squared right, but that's on the left-hand side here of the inequality. But the only reason is because what I told you before when I was deriving or showing you where this came from. Remember, I told you that it was because of our cultural bias is what it boils down to. You remember that thing I was showing you, you know, the chi-squared right is over here on the right-hand side. Chi-squared left is over here on the left-hand side. But this isn't the way we normally write these things. We normally write it to where it's the smallest guy on the left, because in our cultural bias, that's just the way we do it. Our number lines, you know, the smaller numbers are on the left, so we write it this way. So if you can remember this, that's great. If you just have to memorize it, that's fine too. I don't know what to tell you, really, you know. Okay. That's the one thing about this that I find to be slightly confusing. Otherwise, it's all just algorithmic. You got an algorithm. You just plug it in. You could be doing this. You could do this whole problem while you're watching the Kardashians. I shouldn't pick on the Kardashians. Okay, so we've got this formula here. Here's our formula. If I can give you more advice here, always write down the formula. Write down the formula. And then plug in the numbers. Okay, so here they are, you plug them in, and boom, there it is. So what we're saying is that we're 95% confident that this right here, this is the true variance for the population. The true variance of the ages is between 17.2 and 48.9 years. Okay, now does that seem reasonable? Well, you know, I would say it's, you know, pretty reasonable. The standard deviation was 5, right? Okay. Okay, so if this, give me 1 second here. Okay, so this, the standard deviation, which was what was given to us, standard deviation is you know, roughly speaking 5. So if the standard deviation is 5, the variance is 5 squared, which is 25. So what we're saying is that the variance is between 17 and 48. Well, our point estimate was 25, so 25 is in there somewhere. So you know, it's reasonable. It's not, you know, it's not a real it's not a real tight estimate. Okay. Okay, and as the author says, you know, if you wanted the standard deviation, you just take the square root of everybody. So you take the square root and you're saying, okay, sigma is between 4.1 and 7.0, which seems reasonable because based on a sample of 30 women, you came up with 5.2. So 5.2 is in there. So that seems pretty reasonable. Okay, so let's look at the next one here, example 715. This is talking about storms, okay? So I guess there's some rule that basically says that a storm doesn't get a name unless it has a certain characteristic, certain strength, okay? So what this is saying is that 10 times in this year, 15 times in this year, 12 times in this other year, all these different years, okay? That was the number of named storms. So that's how many there were, okay? So you look at this. Now, this particular set of information here, this set of data here, doesn't tell you what years, right? But you could easily see where this would be the kind of problem that you might look at if you were talking about climate change, right? You might want to know, are we more variable nowadays than we were 100 years ago? I mean, what, how much variation is there, okay? Is it really, is it unpredictable more, okay? So that would be something that an example of where you would want to know this. Okay, so easy peasy, right? All you do, you get a 90% confidence level. So your error budget is 10. Alpha is 10%. Alpha, half of alpha is 5%. Random sample of 10 years, so n is 10. So my degree of freedom is 9. They tell you that it's approximately normal. So now it's just a matter of cranking this sucker out, okay? So then it says, well, find the variance, use the formulas, blah, 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 or your calculator. Okay, so I'll let you do that. But if you use your calculator, God bless you. I can't use those calculators. They're too complicated. What I do is just go to to a website. I just Google it, statistics calculator. It gives you thousands, hundreds of thousands of hits. I know I've used, which one have I used? Calculator Soup. I know I've used this one before. That name sounds familiar. So you take a look at this, but you can find your own, find the one that you like. Okay, here we go. Enter data set. So you just type in those numbers that they gave you. And separate the data, the data points, you separate them by commas typically. Here's, this looks a little more complicated than what I'm used to. Let's see if I can find an easier one. You see how pointless it is to spend hours and hours learning how to use your calculator? I mean, it's just craziness. How about this one? Okay, this one says specifically it does the standard deviation. Let's take a look. Boom, there it is, let's see here. Okay, provide the values separated by the comma below. You just type in the numbers, those same numbers that he just gave us in the problem. I wish I could just copy and paste them. I don't think I can, though. Let me close this up. So I could do it. I could, let's see, you have to do it by comma here. Okay, so I could just plug in the commas, comma, 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 comma. I figured I should do at least one of these. I don't want you guys to complain that I didn't do at least one problem on the, okay, calculate, boom. Okay, boom, there it is. I mean, how easy is that, right? So here's the mean, here's the median, here's, all the different stuff, okay? Standard. Okay, so I noticed that I made a mistake there, so let me see if I can fix that. Give me 1 second here. All right, so what I had done was I had put I forgot the comma right there. So let me put the comma there. Go back to it. Okay, here we go. Now I believe this is correct. Comparing this to the book, this gives us the right values. Okay, so as you can see, it's pretty easy. Now keep in mind, this is the sample variance, not the population variance. So 16.9, that's the sample variance. That's exactly what the book has. Okay, so you calculate that, you use the formula, and boom, there it is, okay? So I think it's pretty clear. Just work out the examples, ladies and gentlemen. If you don't work out the examples, you're never going to be able to get this. You're going to be able to recognize it. You'll recognize what I'm saying. You'll understand what I'm saying, but you won't be able to reproduce it, and you won't be able to reuse it. You won't be able to analyze it and put it into new problems. All right, so that's the end of this video. That's the end of this section. That's the end of this chapter.